So, the first thing for our quadratic function lesson today that I want to point out to you on here is that the value of b in our equation is going to affect the axis of symmetry. So the axis of symmetry is that imaginary line that is going to cut your parabola in half, where you would fold it and it would land exactly the same on both sides, okay? Now, realize that the b, like right here, the b value is 2, right here it's 4, and right here it's 6. But that is not where that axis of symmetry is. So b value is 2, but the axis of symmetry is at -1/2, okay? B value is 4, but axis of symmetry is at -1. So there is a formula for finding the axis of symmetry, and it's this. I wrote it bigger right here. It is x equals, so axis of symmetry is always an x value, right? It's on your x line. Negative b, so your b value, divided by 2 times your a value. That's how you figure it out, okay? And so that's the first thing. The second major thing that we need to talk about is that the y-intercept of whatever quadratic function you're at is c. So this is the beginnings of being able to do this without our graphing calculator and get kind of a general picture of what you're going to get without graphing it. Of course, right now you can check it with your graphing calculator. All right, so what is the graph of the function y equals x squared minus 6x plus 4? So what we want to start with, if we don't have our graphing calculator, is the axis of symmetry. So where is that fold line going to be? So what we're going to do is use the formula. So negative b, right? So in fact, let's list them out. What's our a value of this? Go ahead, Xavier.
X to the second.
Nope, that's not x to the second. What is it, Regal?
1.
It's 1. There's a hidden 1 right here. So what is our b value now? -6. And what is our c value? 4. Okay, so to do the axis of symmetry on here and use our formula, it's negative b, but b is -6. So it really is -6. So it's positive, right? Divided by 2. 2 is always there, times a, so times 1. So I just wrote it all out since this is our notes here. And it's x equals that. And so then that equals +6, right? Over 2 times 1 is 2. So 6 over 2 is 3. So that's our axis of symmetry. So on our x line, we find x equals 3. So 1, 2, 3. And so we use a dotted line usually for our axis of symmetry. We know that's going to be our fold line for our parabola, right there. The other thing we know from the information is that the y-intercept is going to be the value of c. So c is 4, right? So this is my y line. So 1, 2, 3, 4. It's going to cross there at 4. And hopefully we can see this on video here. That's your y value. Now, is this going to open up or is it going to open down? And how do you know? We learned this yesterday. Xavier, go.
Because the dot is at the top instead of the bottom.
No, that's not why. Is this going to open up like a U or open down like a rainbow? It is up, Angel. How do you know? So it could be positive. It could, but what if it went like this, though? And went down like a U. So, but let me show you, and I don't want to write on it, but if it could go like this and open down. But there's a reason it opens up that we learned yesterday. Go, Alvin. Nope. That's not the vertex. That's the axis of symmetry. A is positive. Good job, Evan. All right, A. The A value is positive, meaning it's going to open up. All right, so we know that this is going to hit and open up here. All right, let's check in our graphing calculator now. Okay, so if you take out your graphing calculator, go to y equals. Oops, I'm going to clear mine out. Clear out what you've got, and then we're going to put x squared minus 6x, and then plus 4. And then we're going to hit graph. Ooh, I got to change my window. All right, and so my window, I'm going to make it negative 10 to positive 10 again. All right. Okay, and then if I hit graph, it's exactly what we had. It opens up. Our y-intercept is at positive 4, and our axis of symmetry is at x equal 4. And then it looks like our vertex is where? All right, and so let's trace down and see. So it's at about 3, negative 6. Oh, why 3? Oh, I'm sorry, I misspoke. Yeah, 3 is our axis of symmetry. So at 3, negative 6 is where we're going to be at. 1, 2, 3, 4, 5, 6, right here. And I'm going to show you in the next lesson how we're going to find that vertex as well. And this is what it looks like. Easy peasy. Okay? All right, let's do it again. General graph for the got it down here. So what is the graph of this function? Negative x squared plus 4x minus 2. Okay, so again, if you list A and B and C, it does help you out. What's the value of A? Negative 1. So right away, what does that tell you? It's going to open down, make like a rainbow shape, right? What's the value of B? 4. And the value of C? Negative 2. Okay, so we already know it's going to open down. What else do we know automatically? The y-intercept is where? Negative 2. So I can actually mark that right now. I know y-intercept is negative 2. I know that it's going to open down. And the other thing I need to figure out right now is my axis of symmetry. All right, so let's use the formula again. So x equals what? Go ahead, Emma.
Negative 4, and then divided by 2 times negative 1.
Perfect. Negative 4, so negative b, divided by 2 times negative 1, or 2 times a. And then you want to simplify that. So that's really negative 4 over negative 2, which is equal to what? Positive 2. Good. So x at positive 2 is my axis of symmetry. So we can draw our line, our dotted line. We know it's going to open down. What we don't know is where the vertex is, right? And we are going to find that out as we get going. But let's go ahead and put it in our calculator, to double check what we've got. So y equals negative x squared. Let's see if that's on screen. Yep. Plus 4x minus 2. And we're going to hit graph. Oh, yeah. And so there it is. We are correct in everything that we want. Where does it appear our vertex is at? 2 what? 2, 2 about, yep. So 2, 2. And then if we draw that guy in there, whoop. Oops, the marker. And there we've got our graph. Looking good. So we know a lot of things about the graph before we even graph it, right? We can figure a lot of stuff out. Okay, good. That's the first half of the lesson. Here's the second half.
Story problem.
And this is the cool part. As much as you guys don't love story problems, these are super informative story problems. Just the, okay. So I have a whole thing for you guys to write down here. And I'm going to talk about it while you write it down, okay? So in the last lesson, we kind of talked about negative 16t squared plus the value of c. And that was giving us the height of something that's falling, right? Just falling, like the acorn falling from the tree. But what if something is shot out of a cannon or hit from a bat or hit from like a spitball thing, right? Or a slingshot. That's a projectile. That's not just falling. So there is a formula for that, okay? And the formula is this general formula right here. H, the height, which is at any given time, okay, is given by negative 16t squared. And this is accounting for Earth's gravity. Plus, and this is v of 0. This is the of 0 is accounting for the initial velocity, right? The velocity of a projectile does not stay the same as it goes through the air, right? So, like if you were to shoot a t-shirt out of a t-shirt cannon, right? Is the velocity more or less in the very beginning? More, right? The initial velocity is more, and then it slows down. And then the t is standing for the time in seconds, okay? And so we should probably put that down. Time is in seconds for this. And heights are always in feet, okay? So our heights are in feet. And then the last value here, our c value, is the initial height. So sometimes the projectile of something might start from the ground, which would be 0, right? If you're kicking a soccer ball and it's sitting on the ground, then that initial height is 0. However, if you're shooting a cannon from a cannon, the cannon's not sitting on the ground, it's sitting up at an initial height, right? And so we're going to use this formula in a lot of ways. So this is the first part of it. All right, so here's our problem to start us out. So you can see they've got, like, have you ever been to like a stadium or like some sort of presentation where they shoot stuff into the crowd with like that big giant slingshot, usually t-shirts or something? So that's what they're doing here, okay? So it says, during a halftime of a basketball game, a slingshot launches t-shirts at the crowd. A t-shirt is launched with an initial upward velocity of 72 feet per second. The t-shirt is caught 35 feet above the court. So someone's going to catch it up here in the stands, right? How long will it take the t-shirt to reach its maximum height? What is the maximum height? What is the range of the function that models the height of the t-shirt over time? Okay, so our first thing that we want to do is we want to change our general format and put in the information we know, right? Okay, so let's do that. So our height is going to be negative 16t squared, right? That's not going to change. We're on Earth. That's going to be our gravity. Plus, do we know our initial velocity? 72 feet per second, yep. So we're going to say 72t plus what else? Our initial height is 5 feet. So this is the formula that we're going to look at, okay? So our first question is, how long will it take the t-shirt to reach its maximum height, right? Is the maximum height the value of 35?
No.
Probably not, right? It's going to reach a maximum and go back down, and then someone's going to catch it. So let's put this in our calculator. Y equals, again, clear out what you got. So negative 16x squared plus 72x plus 5. And now we're probably going to have to adjust our window a little bit. We know that the initial height is 5, right? Oops. So if I just do it as is, it looks crazy. You're not going to see much at all. So let's adjust our y maximum. let's try adjusting it. We know it's caught at 35 feet, right? So what do you think that we should make our maximum at? 40 or 50 even. I'm going to make mine at 50. And then I'm going to hit graph.
Oh my god.
It went higher, right? So let's try again. What do you think? 75? And I'm going to change my scale also. It's going by ones right now. I'm going to change it to fives. Is it higher? All right, let's go again. I'm going to change my window to 100, and I'm going to make it go by tens. Now I got it. Now I got it. Okay, so let's find the maximum height here. All right, now there is a way to do this exactly. All right, I'm going to show it to you. So we're going to press second, calculate. What do you think I'm going to go to?
0?
Nope. Maximum. This time it's a maximum. The 0 is when it hits the ground. The maximum is going to give us our vertex as a maximum. So go to maximum. And now left bound. Left bound means make your cursor go to the left of your maximum. So press enter if it's to the left. Right bound, now we got to move it so it's to the right of our maximum. Let's do it. And then press enter. And our maximum, so I'm going to write this down here, is at the point 2.25 about, comma, 86. Okay? 2.25 is our x value, and 86 is our y value. What do they represent? Is 2.25 going to be our time in seconds, or is that going to be our height in feet? Time. This is our seconds, which means 86 is our height in feet. So our first question was, how long will it take the t-shirt to reach its maximum height?
2.25.
Yeah, max height is at 2.25 seconds. What is the maximum height? 86 feet is our max height. Yep, hold on. Okay, so these are our two answers that we've got. And then it says, how long will it take the t-shirt to reach, oh wait, no. It's caught at 35 feet. How long? What is the maximum height? We got that. And then what is the range of the function over time? Okay, so the range is the x or the y values? The y values, right? So our y values right here, let's think about this. Do we have any negative y values? No. Okay, we can't have negative feet here, can we? It's not going to start below ground. Is it going to go up forever, though?
No.
No. What's its maximum? 86. So, our range as a, we want to write it as an inequality. How would I write it? What's the minimum? 0 is less than or equal to our, I'm going to say h because that's what we're using for height, right? Which is less than or equal to what? 86. Okay. And they gave us the information that it's caught 35 feet. So does it actually ever hit the ground? No. And so you could figure out, right, if they asked you, which they don't, but I'm going to show you. If you go to second table, and we're looking at for 35 feet, right? Okay, so about how many seconds, and it's not exact, about how many seconds is it after where it's caught? 4, right? Or a little less than, or a little bit more than 4, I'm sorry, right? A little over 4 seconds it's caught in the crowd. Pretty cool, huh? Okay, that's a lesson for today. I'm going to stop the video because that's the notes. And if you have questions, make sure you come